So I will be giving you an overview about the CECAM electronic structure library. I'll try to be brief since we are already a bit late. So what is the idea behind this electronic structure library? So up to a few years ago, in our community of electronic structure, everybody was writing their own code. So we had several codes, and since they were performing more or less similar tasks, we ended up by having a lot of code replication. So each code would implement the same functionality over and over again. And of course, if you do this, you have duplication of effort, which is a bit of a waste of time. So this is a very well-known problem in software engineering, and the solution is to obviously share the code using software libraries. And this is what people started to do some time ago. So for instance, developers of Code 1 decided, okay, we have these nice features implemented, let's extract them from the code and make a library. And developers of Code 2 say, okay, that's nice, so let's start using your library. And okay, might decide that to keep one of their own implementations for various reasons, like they don't like the API of library 1, or they don't like the performance. And developers of Code 3 can also say, okay, we also have the same functionality, but in our case, our implementation is different. It works better in different circumstances, so we are also making a library out of it because it might be better suited for other people. So what we would like to do from here is actually take all of these libraries and bundle them. And all the different code can use directly this bundle and choose the different libraries and algorithms that suits their needs. So, and you will for sure find very familiar the left-hand side of the ESL bundle, where you have an interface for several libraries that implement the same functionality. So this was the basic idea behind the CECAM ESL, but it's not only the libraries. We also have data standards. We try to have documentation, that we would like to make it as extensive as possible. Also a wiki to put extra information about the libraries, and also to centralize information. And most of the work has been done in workshops. So the workshops are also a very big component of the ESL. The ESL itself is made up of the wiki, which you can find at this address. All our software repositories, at least for the software that is developed within the ESL, is hosted in this GitLab from ECAM. There is a curating team and advisory committee, although we try to keep all administrative tasks as light as possible and very flexible. And almost all contributions are from volunteers. So this is very important. So let me stress again the point of the software libraries. So we want to minimize the development and maintenance effort for our code developers. And we know that implementing new features is a time-consuming task, and we don't want to keep reinventing the wheel all the time. And we know that when a code becomes larger, the percentage of the time dedicated by the developers to maintaining it all increases. So we would like to share code so that we can share the maintenance effort. And if we have a larger user base, it's also a way of getting more feedback, bug reports, etc., which allow you to improve the software. And we also would like to disentangle as much as possible the science from the software engineering. Although we still need people that know both the science and know software engineering. We don't want all our scientists to have to learn software engineering, and we want to be able to work with software engineers without them having to learn the science behind the code. And we also would like to keep all the very specialized tasks about code optimization and porting to new architectures and language to the library developers. So for the ESL software, we have a few requirements and coding standards and some recommendations, and it's very important the ESL modules and libraries should be easy to maintain and easy to use. And after discussing with all the people involved, we have a few set of recommendations. So we usually prefer libraries written C or Fortran for which you can provide bindings to other languages. So for the licenses, since we really want the libraries to be able to be used by commercial codes, they should be either LGPL or BSD. Source code documentation is very important, so that other people can understand what the libraries are doing, and we can extend them and maintain them. Should, of course, use a version control system. There should be a standard build system like AutoTools or CMake, and also that the libraries provide proper error handling. It's also quite important when you have large codes that run on very big machines. They should not just stop because a library decided to throw some error and fatal error. So the code should always get back control. So for the last few years, the ESL has been supported by CECAM, and since a year and a half ago, this has been done through ECAM, which is European Union Horizon 2020 Center of Excellence. So it's an e-infrastructure for software, training, and consultancy. It's made up of most of the CECAM nodes, so 16, by HPC centers that belong to the PRAISE European project. There are also many industrial partners and one center for industrial computing. And the objective of ECAM is to create around 150 software modules directed to industrial and academic users. And these are broadly divided in four domains. So one of them is electronic structure, which is the one that is related to the ESL. But there's also classical molecular dynamics, quantum dynamics, and multi-scale modeling. And ECAM also aims to train users to use the software and provide support for end users. And the ESL was used as a pilot project for ECAM. So we are tightly integrated since the start. And as I was saying before, one of the main components of the ESL is the workshops. So these are really unique opportunities to bring all the code developers together and have discussions and also do coding. So these are typically long workshops, so at least 1 week, but ideally 2 to 3 weeks, with not too large team. So between 10 and 20 participants is the ideal. Now these are usually divided into discussion and coding sessions. So the first workshop was already 3 years ago. It was an extended software development workshop at the CECAM headquarters in Lausanne. There were around 10 participants, and there were a lot of discussions. And basically, this is where all the ESL infrastructure was set up, where people decided what was going to be done over the next few years. Afterwards, a year later, we had again a workshop in Lausanne. This was called the Utilities Toolbox. This time was only 1 week. And the themes that were explored and discussed were low-level utilities like memory management, error handling, etc. Further steps towards standardization and tools to handle atomic geometries. Then January last year, we co-organized a workshop with NOMAD, which is also a center of excellence from the European Union, which is a bit has different aims than ECAM, but we had a clear common point, which was the need for standardization of formats, or file formats for computational material science. So this was, again, a two-week workshop, and we discussed problems relating to creating a common data format. And during this workshop, we start setting the specifications for electronic structure common data format, and started developing the associated library to read and write these files. Then also last year, so a year ago in Zaragoza, we had a workshop on solvers, and there were basically 3 projects. So the COMSHAN solvers, which ELSI is part of, and was also Poisson solvers and atomic solvers. There was also a workshop last month, but Stefano is going to talk about that in the next talk, so I won't go into any detail. So what do we have right now, or what do we want to have in the ESL bundle? So this is aimed to be a collection of software libraries, and these are broadly divided into the software libraries developed within the ESL, but we also include relevant software that is distributed within the ESL with the agreement of the authors. So we also provide binding from different programming language and documentation, and at some point we would really like to have a common installer for all these libraries so that it's easy to compile and install the entire bundle. We also like to provide Debian and RPM packages, and also a collection of easy configs for the easy build software, which it's basically a package manager to automatize installation and build of softwares in HPC machines. So what is currently part of the ESL? What is included? So there's a big list of there's a reasonably large list of libraries. Well, some of these you are very familiar with them. I won't go through all of them because I don't have much time. So I'll just mention a few. So my sampling is a bit biased, so I'm going to talk a bit more about the ones that I've been more directly involved with. So, for instance, SleepPSPIO, it's a library for parsing and writing DFT pseudopotentials. So if you have used DFT codes, like plane wave codes, or other codes that rely on non-conserving pseudopotentials, you've probably realized that there are lots of different file formats for these pseudopotentials, and the codes usually are only able to use a few of those. So the idea of the library is to allow code to support as many formats as possible. So for now, we have only non-conserving pseudopotentials, but we plan to have PW and ultrasoft pseudopotentials soon. So there's also libSCDF, which I already briefly mentioned about the workshop on the common data formats. So with this data format, we would like to provide a framework for saving and reading data. The format stores all the metadata that's needed to interpret the data. We don't enforce a specific physical representation of the quantities. And it provides a mean to store different types of data. So atomic geometries, basis sets, densities, wave functions, etc. And it's meant to be extendable and not restrictive. So it's based on HDF5 with support for parallel I/O. And we use the HDF5 hierarchical structure to organize the data in groups, system, basis set, densities, states, etc. So the groups that are common to all codes that support the format at the root of the file structure. But we also provide extensions, code-specific extensions, so that the codes can save specific data using the library. And an important point is that the specifications allow for flexible data ordering on disk for more efficient I/O operations, especially in parallel. For the library itself, we went for a very flexible API, so it's very important that the host code does not have to change the way it stores the data in memory. And the user is allowed to write and read the data in any order. And this is possible because the steps, so the input-output is separate from validation. So first, one writes the data to the files or reads it, and then in the second step, one can validate if the data is correct and or complete. Another project is GridXE. So this, the idea of this library is to evaluate exchange and correlation functionals on a grid. So it returns potentials and energies. It uses libXE for single point evaluation. So libXE is only able to, giving the density and its derivative at a grid point, to return the energy and its derivatives at that point. But if one wants to go beyond LDA functionals, you need to do more than that. You need to compute divergences, gradients, etc. And that's why you need to have the grid and the ability to perform the operations on the grid. Also, this allows support non-local functionals like the van der Waals density functionals. And another thing we started last year is the solvers for quantum atomic radial equations, SQUARE. And this, the idea is to group in one library set of functions and procedures to deal with radial grids and functions discretized on radial grids, how to solve ordinary differential equations on radial grids. And with this, the idea is then to be able to solve radial wave equations on a grid. So basically solve DFT equations for atoms. So about the future, so there's already a workshop planned for February next year. The theme of this workshop is demonstrators, and what we mean by that is that we want to write some DFT codes that use all the ESL libraries. So this will allow to test the libraries in real life application, and ideally to help us to improve the library's APIs, the documentation, the tests, etc. And hopefully we will be able to organize another workshop in 2019, this time in Dublin, in the CECAM node. And this will, the idea behind this will be to start working on the parallelization, the scalability, and the performance of all these different libraries. We're just waiting to know if CECAM is going to fund the workshop or not. So I would like to thank CECAM and ECAM, who have been supporting us since the start, and in particular Dominic Tilsley, that was CECAM director until last year and started the ECAM, all these ideas with ECAM and the ESL. Fabiano Corsetti, Jan Puyo, and Nick Papiol, which have been involved in taking care of the administrative duties, the ESL, Nomad for the collaboration on the ESCDF format, all the organizers of all the ESL workshops, and also, and more importantly, to all the ESL contributors. And thanks for your attention.
Thank you. Thanks very much. Questions, comments, ideas?
Oh, here you go ahead.
Okay.
So let me unmute. Do I need to unmute? Or?
Can you hear? Can you hear?
Can you hear?
Yes, I can.
Okay, yeah. So I have a question on the grid.
Yes.
So one thing is we noticed for meta GGA, and sometimes, especially when the density is small, and the gradient, and you take the second order derivative, things can get large, and then the calculation becomes unstable. And of course, not a question that could be addressed at the libxc level exactly because, as you said, libxc just takes the value of the second order derivative or the divergence, depends on which version, and then spells out the number, right? Actually, this is a pretty serious issue, at least in our code. We contacted Paolo Giannozzi, and actually they observed similar things in quantum espresso as well. But these kind of questions could be well addressed at the grid XC level. Do you think someone is going to work on that in the future to make a stable version of meta GGA, if not even at the GGA level?
Yeah, so I know that some of the problems, the numerical problems, actually come from libxc.
Oh.
So there are some terms that are evaluated by libxc that are diverging. Okay. So typically it's the case when the kinetic energy density is 0 or extremely small, and the density and its derivatives are not 0. And this is a known problem for correlation meta GGAs, which typically have a term that diverges when you are in this regime. So of course, normally once your calculation has converged, if it's a physical system, this condition shouldn't happen or are extremely rare. You shouldn't have the 0 kinetic energy density and a finite electronic density. So there are some papers in the literature to deal with this, and this is something that is already on the to-do list for libxc.
Okay, but this
then,
yeah, okay.
Yeah, so then there's more than that, and there are other problems that come from the evaluation of the potential from the derivatives returned by libxc. And that has to be dealt with at the grid XC level. So I think for the moment there's no support for meta GGAs in grid XC, but once that starts to be implemented, yes, this will have to be taken into account.
Right, that sounds great, because I talked with some people, and they say you just raise the tolerance where you cut off the density, but actually it introduces no noticeable change of the energy and the force. Then it means the result is just not reproducible. It really depends on which cutoff you're using. So having documented and relatively standard, thanks to the pioneering work of libxc, and having this in a single place, I think would be helpful for everyone.
Yes.
Thanks.
Any other question? This is Alvaro. Can you hear me?
Yes.
Good. So, well, I saw a list of libraries there, but so what's the procedure? How you invite people? I mean, Wi-Fi developer for instance, of a different ELSI library, and I would like to contribute to the project. So this is through invitation, or you say, well, I have only, I mean, I already have a ELSI library. I don't need a new one. So what's exactly the procedure, and also if this is only for the European community, or is there a plan to like have this in US too? So yeah.
Okay, so for including libraries in the ESL, that's so the first step is usually to create a wiki entry for your project. There's instructions how to do that on the ESL wiki, and ideally you should also contact the ESL curating team. And if you ask us to include your library in the ESL bundle, we will do it. So up to now we have been both developing our own libraries, but also including other libraries. And I mean, we have no problems in including more than one library for the same type of problem. So if you have another exchange and correlation library and you ask us to include in DSL, we will do it. So we are pretty much agnostic with respect to this.
Okay, so if I include a library, am I committed to maintain it, and is it also a rule for the language that should be coded or interfaced? So is there any standard?
No, there's no standard. As I said, we have a set of recommendations, but that is mainly for the libraries that we are developing ourselves. And this is a library made of contributions from the community. So we don't want to impose our way of doing things. No?
Do you have any connection with MOL SSI? I think somehow it's a sister project developing, funded by NSF US. And I think some of the aims overlap, which is good. So it's, seems like the community is going towards that, but it will be good if there is not a duplication of effort, you know.
Yes, I agree. Unfortunately, I didn't know about MOLSI until last month. Actually, Volker mentioned it to me while we were in Trieste. And funnily enough, a week later, someone else also mentioned it to me. And I realized that one person that I know very well, which is my current boss, is in the advisory board or something like this. So
okay.
Yes,
so
we will definitely contact them because, as you said, it's good not to duplicate efforts, and it would be good to collaborate on this.
Yeah, if I can help in something, let me know. I may be useful, maybe not. I'm useless. Helping to make a connection with MOLSI directors. So there is an effort currently to develop a new software in US for exascale. So the things start to be really active, you know. So when you start things from scratch, you need a lot of people, you know, and to revise what is done. So if I can help, for instance, to connect these efforts to MOLSI, I'm open. Okay, so for instance,
that would be great.
I don't know, to connect with Robert Harrison or Teresa Windows. I may contribute. Okay, so that's okay. All right.
Thank you very much.
Hope you're doing well. Bye.